So you see here, if I apply a force at A, the force will be like this, no? Force will be in the upward direction, and the distance is d1. Now here, if I tie a string to this position B, force will be like this, no? So here, this is the line of action of the force. So what is the perpendicular distance to the axis of rotation? This is the perpendicular distance to the axis of rotation. Here you can see. Perpendicular means it's 90 degree, no? Now if the force is acting like this, then the distance should be perpendicular to this force. And this is the force, no? It means the distance that we measure should be perpendicular to this force. If this is the force, to that force, the distance measured to the axis of rotation, this is the axis of rotation. Axis of rotation. Now this is the force. The distance that we measure from the axis of rotation to the force should be perpendicular to the force. Should be perpendicular to the force. Should be perpendicular. 90 degree angle should be there. Here if we see, if I apply for FB, FB is D2, no? That is D2. And here, if I tie a string to this position, and if I pull it, this is going to be the force acting. So what's going to be the distance? It should be, now this is the force, no? This is the axis of rotation, no? So the perpendicular distance is this one, right? It is DC. This is the perpendicular distance. Here, this is FC. This is the axis of rotation. So to this force, the perpendicular distance is DC. And to this D, this is the axis of rotation. To this D is like this. Axis of rotation is like this. So what is the distance here? That is D. Let's take this DA, this DB, and this is DC, and this is DD. Here you see, this is the force acting. To that force, the perpendicular distance to axis of rotation is this distance, DD, that is perpendicular to the force. Therefore, you can see DA is the largest distance. If DA is the largest, FA should be the minimum force. DA is the diameter of DA is the diameter. But DB is a chord, it's not a diameter. You know, the distance of chord is less than the distance of diameter. Yes. Therefore, answer should be A. Yeah, answer A means what's the choice? First one, 2022, 29th question. Answer number 1. Answer number 1. I have given you a detailed explanation. What is this perpendicular distance? And we say what perpendicular distance, perpendicular. What is the perpendicular distance mean? From the axis of rotation to the line of action of the force, perpendicular distance. Perpendicular distance mean the distance should be perpendicular to this force. If P is like this, the distance is perpendicular to this force. Okay, that's it. This is a detailed explanation. Please note down all the important points and also note down this. If the distance is maximum, force given is minimum. And if the force is minimum, distance should be maximum. The opposite. Force and distance are inversely proportional if moment is constant. This is what it is. If any important points, note it down. Two 2021, right? Sorry, 2021. Question. Now, 2022, 18th question. 2022 18th question. 2022 18th question. What is the advantage of using the handle fixed to a door in the occasion of opening and closing it? Yeah. Yes, but they are asking what is the advantage of using the handle fixed to a door in the occasion of opening and closing? Now you can see in any door, now there will be a point where the door is rotating. No? A point, one part of the door will be fixed and the door will be rotating like this. Now assume that this is the fixed point of the door. Okay, in any door, you can see the handle is fixed away from the is a fixed part now. Now, if the door is rotating through this axis, then that should be the line of action. Axis of rotation. No? Axis of rotation. Axis of rotation. This is the axis where the door is rotated like this. Axis of rotation. So in any door, you can see handle is fixed further away, far distance from the axis of rotation. Why aren't they making the door now? Now this is the axis of rotation. Why aren't they fixing the handle here or here or in the middle or somewhere near to this axis of rotation or in the middle? Why aren't they fixing the handle nearer to the axis of rotation? Because you can see in a door, when opening and closing the door, a moment is created that you know. I have explained to you earlier. This is the axis of rotation, and if I pull this door or if I push this door, a force will be created. That force will create a moment now. So this is what right. Here I will be giving a force. Now here I will be giving a force like this to open or close the door. If I apply a force like this, here I will be applying into or out of the door now. Here I will be pushing the door by giving a force into the board, or I will be pulling the door by, now if this is the handle, if this is where the handle is fixed, this is the handle. I'm going to push the door or I'm going to pull the door. So when I push or pull, I'm going to give a force into or out of the board. That force is at a distance of d from the axis of rotation. This is going to create a moment. This is going to create a moment. You know, as I said earlier, moment is equal to force into distance. If I need to make a minimum force, distance should be maximum from the axis of rotation. Distance d should be maximum. D should be maximum This D should be maximum. If D is maximum, if the distance is maximum from the axis of rotation only, I will give a minimum force. That is why when we are pushing or pulling the door, we are going to push it from the farther away from the axis of rotation, not near to this. If you apply a force near to this axis of rotation, you won't be able to push or pull the door. You won't be able to do it. You should apply larger force to do it. Larger force is needed. But here, if you apply a larger distance from the axis of rotation, a small force is enough. So what should be the answer? 18th one, answer is third. 18th one, answer third. Eloquence of applying a low moment of force. Low moment of force, no, it's not. We are applying a smaller force. Being able to execute a greater rotation, no. The rotation is going to be same, right? Here, it's going to rotate like this. If you give near to the door, away from the door, the axis is, the rotation is going to be same. It's going to rotate like this. It's going to come like this. Go inside, come inside. The rotation is going to be same. Fourth one, reduction of the amount of work done. No. It can be answered, but the most suitable answer is 18th one, answer 3. That should be the most suitable answer. Why? It should be the handle is fixed at greater distance to create a minimum force or lower force. That's it. 2022 done. So all the MCQs and moment is done. And the turning effect of force is done. And now we are going to move the equilibrium part. Equilibrium MCQs. I'm going to clean this. But there are more part 2 questions under this turning effect of force and equilibrium. Will be discussed more part 2 questions. There are only few part 1 questions, but there are more part 2 questions. Unit 12. Is going to be equilibrium. Equilibrium questions.